Now, where did that 200 megabyte per second rule on the last slide come from? Where did we get 200 megabytes per second per core? Well, it's time to meet the fast-track data warehouse reference architecture. Microsoft builds this reference platform for hardware companies to build. Say that you're Dell or EMC or Cisco or IBM, Fujitsu, these big monster companies, and they want to sell data warehouses that they can guarantee to be fast, no matter how crappy your queries are. See, in data warehouses, I can't predict what people are going to query on, and they write heinous queries. They slice by year, by product, by salesperson. I can't predict what columns they're going to pick. I can't predict what they're going to group by, what they're going to order by. So indexes are effectively useless. Microsoft recognizes this, as all data warehouse vendors do, and says, what would it take to build a SQL Server that we could guarantee would produce results at a certain speed, even if you didn't bother to index it at all? So they built this for SQL Server 2012, 2014. Every time they have a new version of SQL Server, they update this, although it takes a little bit of time for them to build this out. And it's not really written for you. It's written for the hardware vendors, but Microsoft just publishes it online. And they even give you tests on how to tell whether or not your SQL Server meets the guidelines for fast track. You don't have to go buy one of these. They're big multi-million-dollar SQL servers, and they're kind of sealed boxes that you're not allowed to touch whenever you implement it. You don't go buy it, but you use this same knowledge to do your own testing. And the thing that this document really centers around is this holistic component architecture. Think of SQL Server as a three-legged stool. There's CPUs, storage networks, and storage. This graphic here is a lot like the photos I was using earlier. Here's my SQL Server. It's got a host bus adapter, or Microsoft has to use different wording, so they call it something no one else in the industry calls it, a host storage adapter, which is technically more correct because it's about storage, not about buses, but whatever. There's the storage interconnect, which is really the SAN, the storage area network. And then there's our storage enclosure, or Dell, HP, Hitachi, whatever storage you've got on the other side there, with a whole bunch of drives in it. They say all three of these have to be equally balanced. It doesn't make sense if you build a monster SQL server and then have a really crappy storage subsystem or a really crappy SAN. So what they actually do is they hook up a SQL server, they build out the box, and then hook up an unlimited speed storage over on the other side. I have a friend of mine at Dell who actually does this. This is his job. Every time there's a new server, he hooks it up to a huge amount of storage and then measures how much throughput SQL Server can actually sustain. In the case of, this is an older box, two Xeon processors with 6 cores each, this thing can consume its maximum consumption rate. It can consume 3,168 megabytes per second of data. Now, you remember the tests I just did a minute ago with my storage, I can only produce 800 megabytes per second of data. So the SQL Server would be sitting around bored waiting for my storage to kick in. In order to produce that much storage throughput, I need 4 8-gig fiber cables plugged in. Now remember, in the real world, you're going to have redundancy, so this actually means 8. I would have 4 plugged into each switch so that if I lost either switch, I could still have the same throughput. That's 8 fiber optic cables going into each one SQL server to do this. This is where SAN admins eyes start to get really big and go, I'm not even sure our SAN can sustain that. And then in order to produce it, if you have old school hard drives, you would need 48 hard drives to produce that level of throughput. SQL Server handles way more data than people expect it to. This is why SQL Server sits around idle most of the time when we're waiting on storage. The starting point minimum of what you need is 200 megabytes per second per core of data. Jumping back a slide, you'll notice that this particular one has 12 cores, 2 6-core processors, 12 cores. If I gave it 200 megabytes a second, it still would be sitting around idle. SQL Server is able to withstand a tremendous amount of CPU power. Now, those are the reference configurations from Microsoft. Then every vendor turns around and gives you more specific details. I'm going to use Dell for a second here just because I do a lot of work with Dell, but all hardware vendors do the same thing. So this is a Dell 720, which is a 2-socket system. This is a 2-socket server here. You could say 4 cores, 6 cores, whatever. Plugged into 2 different network switches or storage switches. In this case, they're saying Brocades, but you can use anybody just depending on which server vendor you're using. And then how much storage you need just to keep this thing busy. If you want to build a failover cluster, they give examples of that too, showing that how each node in the cluster has to be cross-connected to each of those storage switches. They tell you all kinds of details about what exact processors they tested, how fast the network cards, how exactly what HBAs they were using, exactly how they cabled this. So they show you which switch ports they connect to so they don't overwhelm buffers, how they cross-connect between the different heads on the compellant, how they configure the hard drives, how they configure host bus adapter settings, all kinds of minute details in order to wring as much performance out as they possibly can. Some of it is for the database administrator, and some of it is for the storage administrator. And the end result, after you get all the way done, I'm going to use an HP example here just to be different across vendors, is they give you this grid of how fast it'll go. Here's the hardware. Here's your version of SQL Server and Windows. Here's the storage subsystems that they used. They're using PCI Express cards here. Then, after all of that, here's how fast we can scan data off of the storage. And if we do all of that, then we'll be able to balance everything. We'll be able to say that the server can consume this much data, the network can actually provide that much data, and the storage can push that data back across the wire as well. This way, when I run queries, CPU doesn't sit around idle. And Fred says, if you put more of the server's database in RAM, do you avoid this problem? Exactly. That's the cheaper way to fix this, because changing storage is usually very hard. Throwing memory in is relatively inexpensive. I would also argue that tuning indexes is really the cheapest, easiest way of fixing this. We just don't always have that option. Now, all of the vendors out there produce these documentation, Dell, Cisco, IBM, all those guys. So you can find a lot of the common ones, but not all, at brentozar.com/go/SAN, where I've got links to all of the different makes and models. Not all of them, but most of the popular ones out there. The guidance is different for every single make and model of server and of storage. For example, the things that you do on a NetApp are very different than the things that you do on an EMC. Different RAID levels, different storage configurations, you name it. It is very specific on a vendor-by-vendor basis. So in a perfect world, you find the fast track reference architecture for the servers that you're using, for the storage that you're using. You can't always find those, so then you're going to have to step down and go to just general best practices guidelines. And when I get these and I show them to my SAN admin and I say, hey, man, it looks like we're supposed to be using 4 cables or 8 cables instead of just 2. Can you talk about this? Usually the SAN admin says, well, I don't know why you're worried. I'm looking at the dashboard on the SAN and it's always in the green. You're never pushing it out into the red. That's usually because no one's monitoring the network in between the SQL Server and the SAN. And the storage gear, everyone just says, well, the SQL Server's sucking on this straw as hard as it possibly can. The SAN's over there going, come on, can't you get more data than this? I'm hardly delivering any data at all. And no one's looking at the bottleneck between these two devices. Just as if you're a database administrator, I bet you're not monitoring your network ports. If your application developers were complaining about performance, do you ever look at the network port and see how utilized it is? Well, thankfully, that's not usually the problem. It is sometimes, but not usually the problem on SQL servers. It is very frequently the problem on shared storage. especially when we start to think about VM infrastructures or blade infrastructures, where I have one server, maybe it's got a bunch of network cards plugged into this one server, all going into one switch. Then I have a piece of storage gear, EMC, Hitachi, NetApp, whatever, that also has a bunch of storage cables plugged in into a different switch. But then these two switches are plugged in together with a fairly slow cable. No one's monitoring the port utilization across everything in my storage. People just assume I have a lot of cables plugged in, it should go quickly. To catch problems like this, you actually have to get together with your SAN administrator and whiteboard out the entire infrastructure. All right, where's my SQL Server run? Show me all of the ports that are in between here and the shared storage on the other end. What are the speeds of those ports? How many cables have we got plugged in? And what is the port utilization of each of those? Am I restricted to using just one path, or can I use multiple paths at exactly the same time? Again, changing all of this is risky. It's dangerous. It's expensive. It involves outages. So SAN administrators are usually very hesitant to make changes like that. Well, they'll say, like, it's okay for everyone else in the shop. It must be your problem. And it is our problem because we don't have enough RAM to cache all of the data that we're working with. Another reason why the SAN might be sitting around bored is that we might be running SQL Server Standard Edition. Standard Edition has a restriction, or rather, it doesn't have a cool feature that Enterprise Edition has. Enterprise Edition has this merry-go-round reads thing that's buried in books online under a section called Advanced Scanning. And the section's kind of dry. The easiest way to explain this is actually with a diagram, and I kind of like to think of it as interpretive dance. So let's say that I have a really big table. I have a table that's a terabyte in size, and I only have, say, 64 gigs of RAM in my SQL Server. At the time when I run a query and I start reading from this this 1 terabyte table, say I'm looking for all of the sales that involve Ferraris. I start at one end of the table and I'm gradually moving my way through, but the parts of the table I read in the beginning are already disappearing from cache. You might have heard of the metric page life expectancy, which is the length of time in seconds that a page stays in memory before I have to evict it from cache because I need to go read other new pages instead. So in here, if I'm reading through this table, I only have a small window of the table in RAM at any given time. I'm reading through, marching along through this table, and all of a sudden, you start a query. Now, instead of querying for Ferraris, you're looking for Lamborghinis instead. SQL Server Enterprise Edition is smart enough to go, oh, both of you are querying this exact same table. I'm going to use one set of reads so that my query for Ferraris and your query for Lamborghinis look at exactly the same point in the table at any given time. We both get on the merry-go-round. I got on it earlier. You just get on it later. And then as we're reading through this, we're marching through the table together. We get all the way to the end of the table. My query is done. I'm able to step off the merry-go-round, but you continue writing and you only have to read the portion of the table that we didn't read together. This is the only way that you scale lots of simultaneous reads against a table that's too large to fit into RAM. If we were running on Standard Edition, we would both be reading all over the place. We would read the table several times as we start to stack on several users. We would send smaller requests to storage instead of one big, long merry-go-round request, larger read-aheads as we go through. So the way that Standard Edition accesses storage is very different, not just how much memory it can use. Fred says, is this merry-go-round a default feature? Yep, it's on by default. You can't turn it off. It's built into Developer Edition and Enterprise Edition. It's simply not available in Standard Edition. Javier says, is the rule of 300 seconds of page life expectancy still a sign that you need more memory? Kind of. If you're not able to keep stuff in memory for 300 seconds, you might think of that as a problem. But what if your SQL Server isn't waiting on storage? What if your storage is so fast that it's able to keep up with demands and you're not waiting for it? This is why we like to use wait stats instead of general perfmon counters like page life expectancy. I've seen servers that had lower than 300 page life expectancy that were fine, classic example data warehouses. I've seen SQL servers with higher than 300 seconds that were not okay, that were waiting on storage. So I wouldn't use page life expectancy as a primary go-to these days. Helen says, on the VMware, how to store data and log files on shared storage. It all comes back to getting the reference architecture diagrams and manuals from your storage vendor. Generally, your storage vendor will say things like, get the fastest processors in your storage gear that you can, configure them to do as little work as possible, get the fastest cabling that you can, get the fastest drives, put as much flash on there as you can. And this stuff's really interesting when you go in and open SAN best practices guides. They have them for VMware, they have them for SQL Server, all kinds of stuff. The reason why they have all this minute detail is that storage gear these days is very much x64 servers. These are the screenshots out of EMC's manuals about how some of their VNX storage, has one Xeon CPU. On the small ones, it's dual core. On the larger ones of this line, it's quad core. I got SQL servers way larger than that. Then look at memory size. 4 gigs of RAM, 8 gigs of RAM. My laptop has 16 gigs of RAM. Screw 8 or 4 or 8. Come on. Even the high-end one in this range only has 24. How much read and write cache is in use? Look at how tiny those numbers are. Often my storage people will say, don't worry, we have cache. Your writes are considered committed as soon as it hits the cache. You don't have hardly any. Think about for a second a SQL server with 32 gigs of RAM in its cache. If I need to read something, what are the odds that it's not in my 32 gigs of RAM of cache, but it is in the 512 megabytes of the SANS cache? That just doesn't add up. There are cases where this is useful, like advanced read-aheads, where SQL Server's asking for data all in a straight line, and the SAN can pre-populate that whopping 512 megabytes worth of memory with stuff that SQL Server hasn't asked for yet. But that's fairly rare as opposed to SQL Server's good old memory. And this poor SAN, these CPUs and this little amount of memory is being tasked with doing a tremendous amount of stuff. Detecting failed drives, fixing failed drives, deduping data, identifying duplicate data and only storing one copy, doing compression. And some of today's modern storage has truly terrifying features. I know a lot of admins who say things like, I don't want virus scans running on my SQL server. It just slows things down. Your SAN these days can be running antivirus. As a side note, I'm actually completely fine with running antivirus on the SQL server because I see what you people do on your SQL servers, and it's pretty scary. I see a lot of people opening up Internet Explorer on the SQL Server, copy-pasting stuff from web pages, opening applications. So I'm actually totally fine with running SQL Server. We're running antivirus on SQL servers. So stepping back a little then, if we're going to go configure our storage and go configure SQL Server on our storage, I need a whole lot of details about all of these pieces. How exactly should I configure SQL Server on my shared storage? And the vendors are amazing. I'm going to use IBM here just because this is one of the storage subsystems that I've used to work on in the past. IBM Mid-Range Storage System Implementation and Best Practices Guide. IBM's documentation is usually fabulous. Zooming in here on some of the details. This is an 11 megabyte PDF with no pictures. It's hard to generate 11 megabytes worth of data with no pictures, but they managed to do it. We realize that setting up the DS4000 series can be a complex task. Yeah. We later turn our attention to performance and tuning, including apps. There's Tivoli, Microsoft SQL Server, Microsoft Exchange. All right, okay, I'm interested. You go in much further into the document. Testing your own apps with your own data is the only true measurement. Yeah, ain't nobody got time for that. We cover the following topics: allocation, unit size, RAID levels, disk drives, file locations, transaction logs, database, and maintenance plans. Oh, this is very specific. Some of it is for you, and some of it is for the SAN administrator. In this case, for this SAN, need to have a huge disclaimer here. RAID 1 or RAID 10 must be used for the databases, transaction logs, and TempDB. It didn't say it's a good practice, didn't say it would be nice, didn't say this will be fast if, it said must be used. That's not the case with all vendors. For example, with NetApp, you want to use something called RAID DP, which is their proprietary formula of RAID 6. But every make and model of storage is different. Going on to the next page. User database files. General guidelines. Create the databases on a separate RAID array. RAID 5 can be used, but will have slower performance. Consider the speed of the disk. Use the 15K disks rather than the 10K. Avoid using SATA drives for the databases. Gives you all kinds of things about, also keep in mind that the best performance is between 5 and 12 drives. I've seen database administrators on this kind of SAN throw in 20, 40 hard drives and wonder why things aren't getting faster. It's because it has a hugely diminishing number of performance returns after the first 12 drives. You're so much better off creating multiple volumes, each with 12 drives, and this particular storage gear will go faster. Tells you how to configure your cache, how you configure your log files, what kind of drives you should use on the log files. Set your log file to a reasonable size to avoid auto grow. These vendors get really specific. If you go to brentozar.com/go/SAN, scroll down to your vendor, and then you can find exactly the right document that works for your make and model. And it really is dramatically different for every single make and model of storage out there. If your make and model isn't listed on /go/SAN, fire up your buddy Google and search for the make and model of your SAN. Search for SQL.server, that chains these two words together, best.practices or guidance or configuration, and then restrict your search to just one vendor's website. I'm going to start with this just to make sure I get their most recent up-to-date documentation. If it's locked behind a paywall, I may take off this site parameter, and then usually I can find other implementation consultants or resellers who've accidentally uploaded their guides to the site, so then you can just go grab them there without registering or paying for anything. You don't have to worry about the version number. Often, if you're dealing with older storage, there will be guides out there for, say, SQL Server 2005 or 2008. That's all still totally fine. I/O has not changed significantly outside of three things: file stream, file table, and in-memory OLTP. Those three features, if you're using those three features, do change I/O a lot. But as long as you're not using file stream, file table, or in-memory OLTP, generally I/O is all still the same as it was back in the even 2000 days. And when you pop open one of these documents, it's going to be giant. It's going to be huge. It's going to have a ton of stuff that the SAN admin needs to do, and then it's going to have a ton of stuff that the DBA needs to do. And man, I wish I would have found this stuff before I became a SAN administrator, because what I found was that most of the configuration stuff was wrong on my side. Like for my make and model of SAN, I didn't treat the data in log files the exact way the vendor wanted me to. Same thing with TempDB and how I separate where I put my backup files. So what I would do if I was you is I would go download these documents and then go fix my part first. Before I go pinning the blame on the SAN admin, I'm going to go fix my part first. So that then after, because it's not going to be easy, it is going to be hard work, like if you have to move data and log files around. But after I've fixed my part, then I'm going to take this exact same document over to the SAN admin. And here's how I'm going to do it. I'm going to say, hey, buddy, man, you smell great today. Not that you don't always, but even better than normal. God, you just smell fantastic. So by the way, while we're here, I have this document from our SAN vendor, and it says here's how we're supposed to set up the SAN for SQL Server. I'm sure you've done all of this perfectly, but I'm getting ready to start a call with Microsoft because, man, that SQL Server, it sure does suck, doesn't it? And I'm having all these problems with it. I know they're going to ask to make sure that we did everything the way that the SAN vendor said. So can you just show me in the SAN control panel that we've done these things the way that our SAN vendor said we would? Did I mention that you smell great? Often they didn't do it exactly the way the SAN vendor said because some of the stuff is really expensive. For example, if the SAN vendor says you have to use RAID 10 or you have to use a certain percentage of solid state drives, and I don't want to throw my SAN administrator under the bus because it's often not his fault. He had restrictions around what make and model he could buy, how many cables he could plug in at the time, not enough switch space, crappier old switches. And I'm okay with him saying, well, that part isn't relevant, trust me. But the more times that he says that, or the more times that he says, oh, no, we don't do it that way. Yeah, no, we don't do that way either. Then that starts to explain why I'm not getting the best performance out of the SAN than I possibly could. So the top 5 big takeaways here out of shared storage. First off, pathing, the number of cables that I plug into my SQL Server and how I configure those, is usually more important than the drives or the RAID levels or the settings on the other end. I'm going to start by making sure that I have enough straws going into that SAN soft drink, so to speak. 2, SANs are social networks. The shared storage area network is shared by all of the SQL servers that are running at the same time. And when I'm under virtualization, it's also shared by everyone else who's a VM on the same host or using the same storage. Me as a database administrator, I got to stagger my activity. I can't have everyone back up their transaction logs on the hour every hour because whammo, I'm just going to slow everything down. I can't have everybody run CheckDB at exactly the same time. I got to start stepping back and sketching out these job schedules to balance the load as much as I can across my shared storage. Third, in a perfect world, I'm going to get my vendor's fast track instructions, fast track data warehouse reference architecture. If I'm dealing with storage that doesn't have a fast track, that's already my first sign that maybe it's not really the vendor I thought it was. There's a lot of startup storage vendors who are doing all flash stuff these days. They just don't have the resources to go build fast track reference architectures. Doesn't mean they're bad. It just means I'm going to have to work a little harder. Then I'm going to have to get their SQL Server best practices recommendations. But if they don't have a fast track and they don't have SQL Server best practices guidelines out there, this may not be a great storage subsystem. That doesn't mean I can just go say, go get a new SAN, because I don't have that luxury. But it may mean that I have to offset this by throwing memory at the SQL Server instead. Fourth, I'm going to hold my SAN admin accountable by running Crystal disk mark tests and handing it to them and saying, here's what the SAN storage numbers look like. Here's what my laptop storage numbers look like. Can you help me get our SAN closer to my laptop, assuming that you use a solid state drive in your laptop? You can't always get them. You can't say, here's exactly how fast it needs to go. Just start by getting your storage gear to be as fast as your laptop and then go from there. And people always think I'm joking, but then as we do these in the in-person classes, I have people run Crystal Disk Mark on their dev servers, and they're just jaw-dropped at how much slower their dev SQL servers are than their own solid-state-equipped laptops, which is kind of a good thing these days. These days, modern laptops have just gotten insanely crazy fast. And then finally, learn more at brentozar.com/go/SAN. It sounds a lot like I'm bashing shared storage here, and in some ways I am. It's wonderfully reliable. I love it for clusters, for large database servers, but it just doesn't produce the same results in terms of performance as what I can get these days from a $1,000 PCI Express cards. Fred says, I have heard SAN admins say, well, you don't need 1,200 megabytes of throughput. You're only going to put 600 or 700 megabytes of throughput per second. They may be right. Like, it all depends on your workloads. What if it's a transactional server that's just doing inserts, updates, and deletes? It's never pushing 600 or 700 megs. But what about your backups and your restores? This is why we over and over come back to this thing. What if the business says, well, in the event of corruption, we need to be back up within 1 hour? And what if they won't pay for database mirroring or an always-on availability group? Can I restore my entire set of databases within 1 hour? And often, with the human intervention factor, it takes me 15 minutes to sober up, get to a keyboard, connect the VPN, then make the manual decision that I'm going to start the restore process, because you never do that right away. It takes you some panic time looking at CheckDB. Really, you're looking at 30 minutes in order to do the full database restore. Simply time it and say, all right, now suddenly you need to make this go faster, and time it on a laptop. Timing database restores on a laptop, not over a network, because that doesn't work. You're going to be limited by the speed of the network, but using solid state drives inside a laptop. I've got a 1 terabyte solid state drive in my laptop, so it makes it really easy to do that demo and say, I can restore the 100 gig Stack Overflow database in less than 2 minutes. Now we have a production SQL server with a 100 gig database, and the business has said we've got to be able to come up within 1 hour, but it takes 70 minutes in order to do that restore in production. Let's get to talking. That's when you start having those discussions about megabytes of throughput. You may not need it. If, for example, the business says, in the event of corruption, we'd like to be back up within a day, then who cares? You don't need 600 or 700 megabytes of throughput for data unless you're dealing with a multi-terabyte database, in which case you will.